Well, hello everyone. This is Jeff Statz, the Marhide Tech guy. We're here to talk about the new RP17. We're going to be going over the installation and commissioning overview, and we're all excited about this. It's like the new phone books are here. So let's go ahead and start this. So we're going to cover basically our equipment, accessories, components, installation guidelines, air handler, outdoor unit, controller and function codes, strip heater installations, and some thermostat things and resources. Here's our basic nomenclature, RHMV. This is a specific unit. This is not the 20 SEER air handler. This is specific to the 17 SEER variable speed horizontal discharge heat pump. Do keep that in mind when you're ordering equipment. For the outdoor unit, RP17, the only thing that's going to look different here will be the H. The H will tell us that that is a horizontal discharge. The V tells us that it's an inverter, and the X tells us it's a data exchange control wire. So there again, be specific on your air handlers. The first few letters and numbers look very similar to what we would have with our 20 SEER air handler, but there again, this is specific to the 17. Okay, so we have 4 units available. We have the 2, 2.5, 3, and 4 ton. This is a high efficiency piece of equipment up to 19 SEER and an HSPF of up to 10.7. That's pretty good. It's the inverter DC compressor that's digitally commutated. So the EEV will be located in the outdoor unit. It's very similar to the same type of installation we would do with our mini splits. With the EEV being located in the outdoor unit, it's got a compact height and a very quiet operation. This particular controller, we're going to reference this, the RXRN-RU-Z2, which from now on, I'm going to call it the Z2 thermostat. This is the one that we want you to use. There is others available, but this one gives you the ability to do all of the function codes, all of the offsets, all of the scheduling, etc. This is the one we will advocate using. Strip heater kits. These look pretty familiar to you because that's the exact same one we use in our conventional air handlers. There's no difference in the strip heaters. So the basic installation of this air handler is going to be very similar to what we do with our conventional air handler strip heater package. External equipment. They have a PCB that has external and output inputs where we can tell it to turn the fan on the indoor unit. We can have it run motorized dampers, economizers, humidifiers, things such as that to integrate into the system. But it is a separate PCB that needs to be connected to the main PCB of the indoor unit. The wiring kit that will be used to connect to the PCB indoor and to the external output, and they make a box for external installations. It too has a remote sensor for sensing room temperature. I haven't hooked up that yet. That will be coming, but there again, it's pretty basic. If you need to sense from another room or you need to put the thermostat in a secure location, we can put the sensor out in the room for temperature sensing. This thermostat converter, the RXTTRX, this will limit, this is so you can use a third-party controller. I do not advocate using this. It will limit the capacity of the unit. It will limit its variability. It's going to be a single stage unit at that time. So we do not advocate using this. All right, let's talk about some of the indoor and outdoor units. So this is what it looks like, the RH-MV2421. One thing you'll notice about all four of these cabinets, they're all 21 wide, and they are very specific to the 17 SEER installation. So when you look at that coil, if you all can see my mouse, this little knockout on the top of the coil, that little plug, depending on the application of this coil, you may have to relocate that return air sensor. We need to be able to sense that upstream of the coil. And I'll cover that a little more in depth as we go through the install of the coils and such. This here is our air handler control board. As we can see, number one, that has a daughter board that plugs into the main PCB. If there's ever a failure with the PCB, you will need to get the daughter board along with it. Number two is our high voltage output, communication, and power from the outdoor unit. Three is your 4-wire connection for your strip heaters. As you look at that, that's the same plug we use on our conventional air handlers, the 4-wire Molex plug-in. The 4 is the external input and output PCB. This is that auxiliary PCB. This would be the plug-in to connect to that auxiliary board. Then we've got 5, which is auxiliary inputs. 6 is our return air thermistor. 7 is our coil thermistor. 8 not used. And 9 is the switch package 101 for the dip switches, which 1 and 2 will not be touched, but 3 will be enabled. You will switch that to on anytime you have a strip heat going in the unit. What that does, it sets the delay fan off timer, so we can get fan operation on shutdown to make sure we take all the residual heat off of the heat elements. So I would suggest on any installation, regardless of strip heat or not, enable switch number 3, switch it to on. That will be a safety thing we do not want to have to deal with later. So every install, switch dip switch 3 to the on position. So as we look at the indoor unit, we have 2 sets of terminal blocks, one for line voltage, one for the low voltage inputs. Number 1, that's our line voltage, 1, 2, 3, and ground. That probably looks fairly familiar to you, because it is kind of we are looking at a basic mini split connection as we would have with our mini splits. 1 and 2 being line voltage, 3 being data exchange, and then our ground. So our same wires that we would use for a mini split between the indoor and outdoor is what we're going to use on this application. So there again, our power for the indoor unit comes from the outdoor unit, just like our minis. Then as you look at the terminal block number 2, Y1 and Y2 are our thermostat connections. So it's only a 2-wire connection, and it's non-polarized sensitive. So it doesn't matter how you hook them up. So we shouldn't be able to mess this up, I hope. 1 and 2 are our external inputs. This is where we would connect our safety switches, be it float switches, pan drain switches, whatever. This is our forced off function, as we see with other manufacturers. There again, that will have to be addressed through our function settings to enable that to work correctly, but we will cover that shortly. You too see a 24-volt transformer. That transformer does nothing more than run the strip heat sequencers. That's what that's there for. Room thermistors. This is the little knockout I showed you in that coil. So we want to sense upstream of the indoor coil, because if we are using the indoor air handler sensor, we want to make sure we're measuring it before it goes through the coil. We want to measure the true return air temp. Now, as you can see by looking at the chart below, that this is a 10K thermistor. You see it's 10K at 77 degrees, so that's a 10K thermistor. A lot of these thermistors in this unit are not 10K, so be aware if we're doing diagnostics on this, you need the chart for each thermistor. They are not all 10K. This one just happens to be 10K. You can see the little highlight down in the left corner. That is the return air thermistor, the room temperature thermistor. And you can see in an upflow position, we would be downstream, or excuse me, upstream of the coil. So we can sense the actual room temp and not coil temp, coil discharge temp. So as we look at the outdoor unit on the 24 and 30, that looks very familiar to me. 1, 2, and 3 to the indoor unit, with line 1 and line 2 as our main power. So this should be familiar to most all of you that does the mini splits, because basically we've got a kind of a hybrid system here with the basic looks of a mini split on the outdoor unit going to our conventional air handler. So you can see too that there is a discharge pipe thermistor. We see that a lot nowadays on any of the variable speed. There is a thermistor there that is not a 10K. I'm not sure what K it is, but there is charts to be able to compare them to actual temperatures found in our service manuals, which we'll cover a little bit of that later on. Okay, line sets. Let's talk about line sets. So, the one thing nice about this, the 20 through 48, the 2 through 4 ton, they all use the same size line set. That'll be 3/8, 5/8. The 24 and 30, they are good up to 165 feet. We need a 16-foot minimum. Now, don't call me and ask me what happens if we go closer, because I know it can't be good. Remember, there's noise issues, there's oil return. I'm going to tell you what we see right here. That's going to be what, there's no fudge factor, because I don't know what's going to happen. The maximum vertical separation on all units are basically 100 feet, 98 feet, which is great. That's a long ways. So as we look at our 36 and 48, 3 and 4 tons, the same line set, 3/8, 5/8, we can do a max of 230 feet. That's a long ways. With a 16-foot minimum and a 98-foot vertical separation. All good news there. One thing that RUUD suggests is that we do not braze to extend our links on line sets. They'd rather have you use a flared union, torqued to the proper specs to eliminate any oxidation or any other contaminants that may be available if you're brazing. Now, that's not to say you can't do it if you do the proper procedures. Obviously, if you nitrogen purge and you make sure you don't pour a bunch of solder into the piping, you wouldn't have any problem. Standard 3/8, 5/8 brazing, we do it all the time, right? That's what we do for a living. Line sets. Do not reuse any existing line sets from traditional systems. Chances are the sizings are not going to be correct. And who's to know what kind of contaminants lay in the traps of the existing line sets. And we don't want to start a new system off with having something already contaminated on a startup. We want new tubing installed, and there is no application where an existing line set may be reused. And both the liquid line and the vapor line must be insulated. Such as a mini split, we have both liquid and gas in that liquid line. So it has to be insulated or it will condensate. Now the guidelines for connections, these are all flared connections, indoor and outdoor. So we're going to do our typical refrigeration practices that we would do with our minis. There again, we're going to do a nice ream job on the copper. We're going to flare it. Make sure you put your nut on first. Flare it. Put a thin layer of oil on front and back of the flared surface, and then we will torque it to specs. As well as that, we will do our common practices as pressure testing, make sure it holds, check for any leaks, and then we will do our evac down to 500 microns, letting it hold for 30 minutes, and then we can go ahead and open up the refrigerant ports. Now, the 2-ton and 2.5-ton outdoor unit has 4 pounds, 10 ounces of refrigerant. On that 2.5 or 2-ton and 2.5-ton, we can go 66 feet without having to add any refrigerant. We are good to 66 feet. You don't have to pull any out. You don't have to put any in. And we can go up to 164 feet. Now, anything over 66 feet, we would need to add 0.43 ounces per foot for added refrigerant. That's on the 2 and the 2.5-ton. Now, on the 3 and 4-ton, that outdoor unit holds 9.9 pounds, 8 ounces. We are good to 98 feet with no added refrigerant charge. And we can go as far as 230 feet on a total max line. There again, we would be 0.43 ounces per foot after 98 feet. So that's pretty good. Now remember, normally our 3H liquid lines would be what? 0.6 ounces per foot. Well, remember with these units, they're a mix of gas and liquid. That's why they're 0.43. That's going to be our multiplier all the time. Electrically, let's look at them. So the 24 and 30, the 2 and 2.5, we have an MCA, maximum circuit ampacity of 20.8, and a maximum breaker size of 30. So pretty standard stuff. We look at the 3 and 4-ton. We've got an MCA of 39.9 and a maximum breaker size of 40. All standard stuff. Do remember that the electric strip heaters are a separate power source. The indoor unit does not share power with the strip heats. That is its own power. Remember, we get our power for the indoor unit from the outdoor unit. So the wiring between the indoor and outdoor is what we already use for the mini splits. 14 gauge stranded, non-shielded, 4-conductor wire. Whatever it is you're currently using for your minis, that's probably what we're going to use for this application. They always say on this, leave your ground wire a little long. That's probably because the ground screw's a little bit further away than the actual lug for the power. The operating range. So the 2.5 or the 2 and 2.5 will cool down to -4 to 115 degrees. And in heating, it's good from -4 to 75 degrees. Now the 3 and 4 ton, that goes to 14 degrees in the cooling mode to 115, and in the heating mode, -4 to 75 degrees. Pretty good range. And what does that tell you about the cooling? It's already got the built-in low ambient. If we can cool down to 14, we're low ambient. Installation clearances. So depending on whether you're in a box or you've got limited obstructions, this usually isn't our application. Normally we're going to back up to the side of the house or the back of the house with very limited obstructions. And in that particular case, on the 2 and 2.5, we can be as close as 4 inches to the back of the coil from the house. And on the 3 and 4 tons, we can be 6 inches. Do keep them clearances in mind. That'll probably be the ones that are most applicable for our installs, is just backing up to the house, give it 4 inches for the 2 and 2.5 and 6 inches for the 3 and 4 ton. In multiple outdoor unit applications, in the install instructions, it'll show you how you would need to lay those out if that was a rooftop installation or a side of the building or what have you, how much room you'd need between them, what obstacles are in your way, and how to space these out to make sure that we get the airflow necessary for good heat exchange. Air handler installation. Take a look at that air handler. Does that look familiar? Well, it is. It's our same casing that we use on all of our air handlers. And the installation is going to be just like we would do on any air handler installation. The only difference is on this cabinet is what's inside. The outside installs like your standard conventional air handler. And you know, it's a multi-poise, so upflow, downflow, horizontal, left or right. Now, as with our standard air handler, you may have to swap the coil. You may have to orient the coil differently, change it around to make sure that we get the right input on the air, to keep the condensates on the bottom of the unit, regardless of whether it's downflow, upflow, or horizontal. So there again, look at the knockouts that are available. So depending on which way the airflow goes, we may need to relocate that return air sensor, and it needs to be upstream of the coil. Always keep that in mind. If you're upflow or horizontal left, you won't have to make any changes. The only changes on that sensor would be if you were downflow and horizontal right. It kind of shows it here a little better. They're highlighting the room thermistor in each of the applications we've talked about, at least horizontally here. You can see that they've relocated the thermistor depending on which way the air flows through the coil. Pretty basic stuff. It's a fairly simple change if you need to move from one location to the other. So you would disconnect your sensor, pull your coil out, swap your coil direction, and then relocate the coil in the other knockout. So as we look at it, we can see it's our conventional air handler with the electrical knockouts, top and either side. So we have good access for electrical no matter where it is. And as we look at the coil cabinet itself, it is the same coil cabinet we would see on our conventional equipment. Only difference being the gas and liquid line are flared fittings. So what does that mean? When you are tightening up those flared fittings on that coil, there's no backup on that tubing. You must use a backup wrench. So always use a backup wrench anytime you're flaring anyway. It's good practice. keeps things together. Another look at our coil cabinet. You can see that we've got plugs in our liquid and suction lines. The flare caps are already on the units. You will pull the flare caps off, take the blind washer out, take the rubber plug out of the suction, and then you will do your flaring, your standard flaring techniques like you would do with any other Mini, and make sure they're good and solid flares. And then as we look at our horizontal drain, or our drain accesses, one always being, three always being the main drain. One is our horizontal overflow, two is our vertical overflow. So we use the same connection we use on all of our coil, all of our drain pans. There's no difference. Now, there again, when you are running ECM motors, you need to run deeper traps. So we need to be at least 3 inches on our trap depths. That way we're not sucking air back into the drain pan and have a major water problem. And you will sometimes see that if you're doing the short traps on ECM motors, they can pull a lot of air and they could pull that water right out of the trap, right up into the drain pan. And we wouldn't be draining then, and we would have issues. There again, we're looking at the low voltage terminal strip on the indoor unit. You can simply see that 1 and 2 is our emergency stop, or our off switch button, which we would have to program or set up through our function 46 setting number 3. We'll cover these settings here a little later on, give you an idea of how this is set up. They show it again, terminal strip, low voltage terminal strip, 1 and 2. That is where we will make our safety switch connections, depending on what it is. Remember, it's a dry contact. All we have to do is close a switch, and we can program that to be a normally opened or a normally closed, whatever the application may be. Could even use it commercially with smoke fire, things such as that, where we disable the unit, turn it off completely. So there's our indoor unit from the outdoor unit, basically 1, 2, and 3. Now they're showing a disconnect. There again, as with mini splits, we do not want a disconnect, not unless it is mandated by code, which would have to be a commercial application. But most of our applications, we will not require a disconnect. So it should be a straight run from the outdoor unit to the indoor unit. And there again, they're showing Y1 and Y2 as our low voltage connection, our 2-wire low voltage to the thermostat. And a little more. The indoor unit, as you see it, 1, 2, 3 in ground. We ought to be pretty familiar with that. There again, 1 and 2 is power, 3 is data, and then you have your ground. There again, Y1, Y2, that is our Z2 wires to the thermostat. Pretty cut and dried. It looks fairly simple for a hookup. Okay, let's check out our outdoor unit installation. Boy, they're beating this to death, huh? Line 1, line 2, outdoor unit connections, and then our 1, 2, and 3 to the indoor unit. That is our mini split connection. No difference. So there again, the vacuum process. We're going to use all of our decent refrigeration techniques. We're going to do our good flares. We're going to put a little oil on them, tighten them up to torque specs. We are going to pressure test that at 500 pounds, make sure that we are not leaking. And then we're going to start the vacuum pump, and we will pump down to 500 microns, just our standard refrigeration practices. No difference. Now, don't look down at them torque specs down below. That's for blank caps. That's for tightening up the caps. That is not what we would use to torque specs. We are going to follow the same torque specs that we follow with the other manufacturer, which is, we'll cover that here shortly, but it's the same settings you would get on your digital torque wrench. Outdoor unit settings. On the 3 and 4 tons, there are a set of control dip switches and a push button switch 1. Those would be pretty much not used. The only reason we would do that would be for a test operation or pump down. If we were doing a pump down operation, we would switch to either heat or cool mode, which is switch set 1, number 1, switch heat, switch cool, and number 2 would give us the ability to use during the pump down operation. And then you would push the switch number 1, the button, to start that. That's if you're doing a recovery mode or something like that. So basically, we really don't need to do anything on that outdoor unit unless you need to do a pump down function. Okay, controls. As you can see, we are showing 2 different controllers, 2 different thermostats. The one on the left, that is our simplified controller. Basically, that's just an up and down in a fan mode. There's not a lot of variety in that controller. We simply advocate using the Z2. It's easier to follow. It has the ability to do the functions and settings, which will be critical to operation. Now, these can run as a primary and secondary thermostat on a 1 unit. I do have that set up here in the training room at Marhigh, just to see how they function together. So basically you can have the primary and a secondary, and all it does is you can change settings, and it changes in both controllers. I don't know where that might be applicable, but it is something that is available. The first thing, when you get your Z2 thermostat and you go to open it up, they've got little latch pins, 2 latch pins on the bottom of the thermostat, the base of the thermostat, and all you have to do is push them in and lift off the cover. These are not pry pins. Don't stick your screwdriver in there and twist it. That's not what these are. You simply push your screwdriver in to unlatch it and lift it up. Now, once you've got it lifted up, you'll see on the back of the thermostat, there is 1 dip switch. That needs to be turned to on. That is what energizes our battery, our storage battery for that thermostat in case we lose power. Now, if you don't set that and you lose power, you may have to go back and reprogram the whole thermostat. So this is one of your starting functions. When you're ready to install the thermostat, turn the dip switch on. So 2 things that must be done on this installation. There's a dip switch in the furnace that needs to be switched on, and there's a dip switch on the thermostat that needs to be turned on as well. Here's your look. It doesn't look real fancy, but it has everything that we need. No colors, but there again, it's very functional. So as we see this Z2 thermostat, we'll go through the menu items and kind of give a brief description of what we have with this controller. Let me go back on that. So you tap main menu. From the main menu, you will see 2 pages. You'll see it listed 1 of 2 and 2 of 2. That gives us access to the submenus. And with every submenu, there may be a variety of pages as well, 1 to 3, depending on what the submenus are. So we'll scroll through. If what you need is not on the first page, hit the next page symbol. That'll take us to the next page of the main menu. There again, we're accessing submenus within the main menus. So when you go to initial settings off of the main menu, we have 3 pages of initial settings. These are your basic things. Language, temperature, which is Fahrenheit, Celsius, your dates, the name of the thermostat, whether it's living room or main room or whatever. The page 2 of 3, RC settings, passwords, master indoor unit settings. And if we were to push the submenu within the submenu on display settings, we go ahead and tap that. And basically what this is do you want your filter sign visible on the thermostat and the room temp as well? Yes, make those visible. I don't know why they put invisible, but make them visible so they can be seen from the main thermostat. It'll tell us when the filters are ready to be changed, and this will give us an actual room temp display on the thermostat itself. So you would go through that, highlight room temp, you'll see visible or invisible, push visible, and then it'll say okay, you push okay, and you can back out to the display item settings or back to the sub menu before that. Everything is a back out. Usually when you do these type of controllers, you'll go through a function and you will back out of it to the next menu or even further back to the main display. Okay, so access function codes. Now this is kind of important because this is where all the settings will be made. As like our other manufacturer with the square thermostat that we use field settings, these are function settings. Basically the same type of thing. Push your menu. That'll give us the 2 pages of the main menu. We will scroll through to the second page by pushing next page. We will push the maintenance button. That is where our functions lie, within the sub-menu maintenance. We will go to the maintenance menu, which has 1 of 3 pages. We will hit next page to get to page 2 of 3, and you will see the sub-menu function settings. Push that button, and you will see the address, function number, and setting number. Starts out at 00 and setting 00. We're going to change that to whatever our function mode is, and we'll scroll through it. So when you highlight function number, you're going to get the numeric value and an up and down arrow. And you will scroll through there to get to your function number and push OK. Now, one thing nice about these functions, these function numbers, they scroll through fast. And you can back up. So if you pass it, you can scroll from 0 to 99 in about 4 seconds. So it does scroll through very fast. But you can back up. That was some of the things that we had with some of the issues on our other manufacturers, is you had to start over again. Not with these. You can go up and down, find the number you need, hit OK, and then you're going to see the function settings mode where it says settings. So you've already set your function, hit the setting button, And then you're going to see the same numerical value display with the up and down arrows. And then you will go ahead and make your setting function choice, push the OK button, and then back out to your submenu, or actually stay in that function setting, because there will be several other functions that you will need to change. Then once you're done with all your function settings, you can back out to the submenu, and you can push back again. It'll take you to the main menu, and you hit it again, and you'll go back to the monitor. That's how they call the main display, is monitor. So when you see monitor, tap that button. That'll take you back to main display. Okay, let's talk about some function settings. The external input control. This is our operational force stop mode. There again, we talked about the number 1 and 2 on the low voltage terminal to be our safety switch. Here are the options. Function number 46, our settings are 00 through 03. Right now, I've gone through most of these function codes to find the one that best fits our application, and at this time, it's 03 for that function code 46. Function code 61. This is what sets the format for the strip heat function. There's many different variations to how you can bring strip heat on, whether you want strip heat to be primary and the heat pump secondary, or whether the heat pump is primary, strip heat secondary, whether we're controlled by outdoor temp, whether we want to lock out our heat pump altogether. So I have gone through this, and I have come up with my own codes that seem to work the way that we are used to seeing heat pumps work. Basically, outdoor limitations. We're going to set an outdoor temp that no strip heat beyond this point. And then if we do get to the point where we need strip heat, we're going to set a differential off of set point within the thermostat of when the strip heat will energize. And I've tried to go through this so it would be very conventional, like we would see in a standard heat pump system, meaning, 35-degree heat strip lockout. Once you drop below 2 degrees past set point, we will energize the strip heaters, and then it will terminate within 1 degree of set point. So Marha has made up a little startup guide, and in that startup guide, we have given you some settings for some functions, and basically I've gone through this, and we have put down some numbers, some setting numbers that will give us basically that type of function with the strip heats. It's hard to kind of disseminate what all these different applications are for function 61. So I've went through them and came up with some picks that I want you all to use. It's more in line to what we're used to seeing with a standard heat pump. Function 72. This is backup heat. This is for operation of our strip heaters. If you do have backup heat, you do want to use this function. What this is this will turn the strip heat on anytime we have an outdoor lockout. If we have any faults that occur in the outdoor unit, in the heat pump, that enable it not to operate, it will automatically switch to strip heat operation. So if you have strip heat installed, enable this function. 92, function 92. This is plus or minus 10% airflow. So if we need to increase our airflow in heating, if we need to decrease in heating, or increase in cooling and decrease in heating. There's a variety of things. As you can see, we've got 8 different selections, eight different combinations of airflow up, airflow down, no change, plus change, minus 10, plus 10. Start off with 0, 0, no change. Looks to me like that's going to be our standard setup. This would be in applications where you might have extended run lengths, extended ductwork, and you may need a little more air on the cooling side, maybe not so much on the heating side, or you can even decrease it if need be, and these are plus or minus 10% on each mode. There again, you'd have to look at this chart and see what was applicable for what you're trying to do. Function 11. So that tells us how much dirt do we want on our filter. How often, how many hours until you get the display that says change filter. Pretty standard issue, especially with the other manufacturers. We have a function 30 and 31. This is a calibration of the indoor room thermistor, the one in the coil, the one upstream of the coil, and this will give us a plus or minus 8 degrees of calibration. If we know for a fact that it is out of calibration, we can change it up or change it down in heating and in cooling if they're different sensor readings. Same goes for the indoor remote controller, the Z2 thermostat. We can change the sensor in cooling and we can change it in heating as much as plus or minus 8 degrees. Now be careful on this. You want to make sure if you're doing any calibrations that whatever you're using to calibrate it is accurate. Don't be using that $5 mercury thermometer to calibrate this sensitive equipment. Function 42, room temperature sensor switching. Must both be set to 1. So what you'll see here, there are functions that you have to turn on before you can turn on other functions. So this is another reason why we've gone through and Marhai has built this startup guide. So it'll tell you, okay, turn this dip switch to on or turn this function on, and then we're actually going to make the changes in another function number. So they kind of work together. One function will say, yes, we're going to enable, and another function will actually give you the ability to make the changes or set the parameters for that function, if y'all get what I'm saying. Function 40, auto restart. Always keep this enabled. That just means that if we have a power outage, it'll go back to whatever you were set at. No changes. 42, room temperature sensing. Now there again, we've already went to both 01 on function 42, and this is going to let us set up for what we do later on, trying to limit the sensor to just the remote controller, just the thermostat. Number 43, cold air prevention. So this is where we try to reduce the airflow in the heating mode, in the thermal off mode. At this time, I have not found a thermal off for the fan. If we leave it disabled, it will follow the settings on the thermostat, the fan setting speeds. If we enable, it will take it to low in the thermal off mode, which I know sometimes can be kind of tricky in the heating mode of having a fan that constantly runs. There again, you know, people don't like air blowing on them when it's not got heat in it. So I'll be working on that, trying to find if there is a function I can get them to actually turn off. But at this point, enable function 43. That'll take it to low in thermal off. Okay, 48, room temperature sensor switching. We actually went ahead on 42 and we function 42 and switched to 1. 1 means we're using both the indoor and the thermostat sensors. In function 48, we can just pick the sensor in the thermostat. So, but you got to set 42 to both so that you can go to function 48 to set it to just the remote controller. So there is some wildness to their madness here, but that's how this will go. On our startup guide, we'll have this all listed so that inevitably when you get done doing all of the settings, our temperature sensing will be done at the thermostat. So indoor unit fan control, function 49. This is the same function as the one we talked about in heating, where we slow the fan down during the thermal off mode. We would enable this function, and it will take it to low in the thermal off mode in cooling. That's function 49. Function 60. This is the function that you would use with that external PCB, that input-output auxiliary accessory PCB for fresh airs, dampers, economizers, etc. With function 60, we'll set the parameters on what we want to, are we measuring input, output, what is it we're switching? We'll set that up with function 60 when you're using that external PCB. Then we got function 62. That sets the external heater off temperature range. And 66, that's zone boundary temperature A. This one you will leave set to 00. This is to lock out the heat pump. Now, I've always advocated there's no reason to ever lock out the heat pump. Even in the worst case scenario, it makes more heat than strip heat for the money. So even if it is cold out there, and technically we are a factory default on that at 00 setting at -4 degrees. Let's hope we don't see that, but at -4 degrees, that will lock out the heat pump, and you will run only on auxiliary heat at that time. That's a built-in, that's as low as we can go for a heat pump lockout. But there's no need to ever need to change that. The zone boundary temperature B, function 67, this is actually our heat strip lockout. This is where we will set the lockout of the strip heat to a minimum temperature. There again, I've got those settings on our startup guide. Basically, 6 is 32, 7 is 35. So I gave you 2 options. Pick what you like, and that'll keep the heat strip locked out till we make our minimum outdoor temperature, or lower than our minimum temp. Function 71, standby for auxiliary strips. So basically it's a time delay. If we are calling for strip heats, we'll set a time delay between the strip heat and its actual call. That can be from 2 minutes to 99 minutes. It's whatever you choose. I choose 5 minutes. Function 73, the emergency heat function. So basically, we are unable to switch the thermostat to an emergency heat setting. There is not one. Mind you, we've already done our emergency heat strips if we have a failure of the outdoor unit, but we do not have the ability to physically turn emergency heat on with no heat pump. It can be done, but it takes an infrared receiver, and there again, it is not supported by RUUD. So we are not going to see this. Remember, your strip heat functions are on the automatic mode, and anytime there is a shutdown of the outdoor unit, an error code, it will automatically go to the strip heat mode. Fan time delay. Remember, we already set the dip switch on the indoor unit because we know we're going to be using strip heaters. We switched on the fan off delay, and from function 674, we'll set the seconds of time delay that we want. Now, mind you, if there is strip heat installed, we want it set for 60 seconds. Factory default is 60 seconds. So you won't make a change on that. You just got to make sure you flip that dip switch in that air handler so that it will give us that fan time delay off. Function 75, external heaters and defrost. So if you have strip heaters, you might as well use this function. Enable this function. So what that'll do is during defrost mode, like our typical equipment, the indoor fan will continue to run. The strip heaters will come on during the defrost mode to temper that air, so hopefully it's neutral. The unit will absorb more heat to actually make it a quicker defrost for the outdoor unit, because it still absorbs heat in that coil, and that indoor coil, and it helps to defrost the outdoor coil with the heat being absorbed. It makes for a quicker defrost. So that's something we would enable if we have strip heat. But now if you don't have strip heat, because these things do perform pretty well, between down to 5 degrees, we only lose a few thousand BTUs. And if you choose not to use strip heat, when this unit goes into defrost, it'll do just like the mini splits. It'll shut down the indoor fan until the defrost is complete. It'll reheat the coil, and then the fan function will start up again. Very similar to what we do with the minis already. Function 93, airflow adjustments. Now what this does, this sets the airflow adjustment. This sets the airflow adjustment based on the strip heat. So depending on what strip heat you got, you're going to set that setting so that it will have enough minimum airflow to facilitate that strip heat, which we will cover. What we're looking at here is when we install them strip heaters, this is where that dip switch is located. There are 2 sets of dip switches on the main PCB of the indoor air handler. And we will go to switch set 101 and flip the switch number 3 to on. There again, that enables us to be able to use the offset fan delay. There again, our knockouts for our blower covers are exactly what we would do with our conventional air handlers. How did we end up? We're way back. So this here, the outdoor intrical heater control, setting number 9, it shows how they've actually got the strip heaters to be locked out via outdoor, indoor, with the strip heats, and then a lockout of the heat pump below -4 degrees. This is a combination. As you can see, there are several different combinations. And I have chose combination number 3. Setting 61, there again, that's our heat pump lockout. I think we've been through this. Backup heat zone, 00 on your backup heat is a disable. 01 is enabled. This is what it looks like on that external heater used for defrost, enabled. Here is that airflow adjustment for function 93. Now, as you look at this, look at the CFMs. See what CFM fits that air handler to fit that KW package. For instance, I have a 2-ton here at the training center. I have it basically set up for 10 kW strip heat. Well, we want to use function 3, seeing that our CFM minimum is 710. That will suit a 2-ton unit. If you look at 04, that has a CFM minimum of 1070. Can't do that with a 2-ton. That has to be the 2.5-ton or the 3-ton. So keep that in mind depending on which air handler you have. So we talked about the emergency heat on during any of the outdoor unit lockouts, and any one of these error codes that you see will initiate that function. So anytime it sees these error codes, it will automatically convert to strip heat operation. And there's quite a few of them. Let's hope we never see them, but that is kind of nice that it's an automatic function. So if the outdoor unit has a error code pop up and it's locked out, if it locks the unit out, you will automatically go into backup heat operation. Now, the resources that are available for those of you that have my RUUD accounts, you go to PTS, Product Technical Support, and this is where you'll find everything really. This covers all of RUUD products, but there again, that's where you're going to find the resources here for the new 17 SEER heat pump. They're inputting new stuff every day to try to fill this up with all the information necessary for this new RP17 horizontal heat pump. And it'll cover, you know, on the indoor unit, all of the installs, operating, service manuals, spec sheets, specification sheets, etc. On the outdoor unit as well, same thing. Covers everything as you would, and the thermostats as well, including the Z2 and the simplified. There again, we are advocating the Z2 only. So this is something Marhi has made up to help with everybody in the field so they get a good grasp of what we're trying to do with this thermostat installation guide. So there again, 2 pages of main menu. Within them pages are sub-menus, and even some of the sub-menus have sub-menus. So the best thing I've always said about thermostats in general, just push the button, scroll through what it does, make the changes that you need to make. But we've actually made it quite simple for you to follow this page by page, menu item to sub-menu item, to give you a better idea of what you're looking at. We've already broke it down so you can see it. As well as we give you functions and setting guidebook. It shows you how to go through the main menu to get to the function sub-menu to make all of the function changes that you would need to make. And to the right of that, there is our functions and setting guide. This makes life a lot easier. We basically have gone through this thermostat, looked at what functions best suit our application for this region. Now, mind you, this is the Northwest, so we did our standard stuff that you might see on a conventional heat pump as far as heat strip switching, them kind of things. And we've laid it all out for you. As you can see, code 60, setting 60, function 62 setting 13 and 14, those are the different temperature ranges within the thermostat to bring the strip heat on. Because there is a lot of different formats that are laid out as to electric strip on, electric strip off. These work as well as the outdoor temperature B boundaries, number 67. As you can see, number 6 is 32 degrees, number 7 is 35. So we've given you a range, even though there is 15 different temperature ranges on those settings. What we've done is pick the ones that will work best for this region to make it easier on y'all out there in the field. And then we gave you a little service information showing you how the fault codes are read at the outdoor unit PCB. This is one of them deals where you got to look at the lights, count the blinks, and then we will disseminate that into the error code. And then additional information where you can find it, what's available, and all of the added info that you would need to know this unit very well. We will be sending out the startup guides on every indoor unit. So what we have just discussed will be available for you on every indoor unit. And my suggestion, leave those on the job. You might not be the only guy to ever work on this system. And without it, you're blind. You'll have to go find out where all this info is. So I do recommend that we leave these startup guides on the job. Kind of helps with thermostat programming, etc. One more thing. If you need to see a running unit so you can see how it operates, you can make an appointment with Matt Schmidt, and we have an operating unit in our training room and give you a quick rundown on how it operates. So thanks for your time. Hope you got something out of this, and if you have any more questions, give us a call.